Unit 5, Property and Power, Mutual Gains and Conflict. In this unit we consider how institutions and power determine outcomes or allocations, evaluate these allocations using the Pareto efficiency condition and fairness criteria, show how policies can improve outcomes. Institutions refer to rules of the game and they matter for social outcomes. Institutions can affect the income that people receive for their work. Evaluating outcomes. Pareto efficiency. Allocation refers to outcome of an economic interaction, describes who does what and who gets what. An allocation is Pareto efficient if nobody can be better off without making somebody worse off. In the pesticide example we have seen before, II, Pareto dominates TT, since at II both Anil and Bala are better off. Payoff at II is 3-3 compared to 2-2 at TT. II, IT, and TI are all Pareto efficient because as you move from one combination of strategies to another, one player is better off but the other one is worse off. Pareto efficiency. Caveats. Often there can be more than one Pareto efficient allocation. Pareto criterion does not help us choose among these allocations. Pareto efficiency is unrelated to fairness. Many allocations that could be unfair are Pareto efficient. Example, giving to your friend 1 cent of the $100 you found on the street. Fairness criterion. Allocations can be considered unfair for two reasons. 1. Inequality of final outcome. Example, wealth, well-being. These are called substantive judgment of fairness. 2. How they came about. Example, force versus fair play, equal opportunity, conforming to social norms. Procedural judgment of fairness. We will talk about Raoult's veil of ignorance in chapter 19, which suggests a very impartial way of deciding on a distribution. Fairness and economics. Economics does not provide judgments about what is fair, but economics can clarify how institutions, rules of the game affect inequality. Trade-offs in the fairness of outcomes. Example, giving up equality of income for equality of opportunity. Which public policies can address unfairness and how? Determining allocations. The feasible frontier shows Angela's hours of free time on the horizontal axis and bushels of grain on the vertical axis. Each point on the feasible frontier shows the maximum of the two goods, free time and grain, that Angela can have. If Angela has 24 hours of free time, then bushels of grain will be 0. With 0 hours of free time, maximum grain produced will be 12. Angela faces a trade-off between grain and free time. Each extra hour of free time is associated with a fall in the amount of grain that is produced. The slope of the feasible frontier gives us the marginal rate of transformation, MRT, of free time into grain. MRT gives us the trade-off that must be made to get each extra hour of free time. Initially, she farms the land by herself and keeps all the grain. Let us now look at Angela's preferences as revealed by her indifference curve. The slope of the indifference curve gives us the marginal rate of substitution, MRS, the rate at which Angela is willing to trade grain for free time. Recall optimal decision making. Unit 3. Allocation is where MRS equals MRT. The graph shows this is at point C. Angela will choose 16 hours of free time and 9 bushels of grain in equilibrium. Let us now change the rules of the game and see what happens to Angela's choice and what she gets to keep. Bruno is not a farmer but wants some of Angela's grain at gunpoint. The combined feasible set shows all possible allocations of production between two parties. Combined feasible frontier is the same as before. However, now the total grain produced has to be shared by Angela and Bruno. If Angela has 12 hours of free time, the grain produced will be 10.5 bushels as shown by the feasible frontier. If the distribution ends up at point E, then they each get 5.25 bushels. To find Bruno's share, we go from point E to the point on the feasible frontier corresponding to 12 hours of free time. For Angela's share, we go from point E to the horizontal axis. Point F shows an allocation in which Angela works more than at point E and gets less grain, and point G shows the case in which she works more and gets more grain. The chosen allocation depends on institutions and policies. Feasible allocations. The feasible frontier shows all the technically feasible outcomes limited by technology. The biological survival constraint shows all the biologically feasible outcomes limited by survival. If Angela does not work at all, she needs 2.5 bushels to survive. Point C. If she gives up some free time and expends energy working, she needs more food, so the curve is higher when she has less free time. This is the biological survival constraint. Points below the biological survival constraint are biologically infeasible, while points above the feasible frontier are technically infeasible. Given the feasible frontier, there is a maximum amount of work above which Angela could not survive, even if she could consume everything she produced. You can see that if Angela is made to work more than the maximum, the biological survival constraint shows that she will need more grain to survive than what can be produced with that amount of work. Feasible allocations are given by the intersection of these constraints. Coercion, imposing allocations by force. Suppose Bruno can enforce any allocation he wants. In effect, Angela is his slave. Bruno wants to find the hours of Angela's work for which the vertical distance between the feasible frontier and the biological survival constraint on the figure is the greatest. The amount that Bruno will get if he implements this strategy is his economic rent, a payment or other benefit received above and beyond what the individual would have received in his or her next best alternative, meaning the amount he gets over what he would get if Angela were not his slave, which in this model we set at 0. He considers letting Angela continue working 8 hours a day, producing 9 bushels as before. Bruno could take 5.5 bushels without jeopardizing his future benefit from Angela's labor because he will give Angela 3.5 bushels she needs to survive. This is shown by the vertical distance between the feasible frontier and the survival constraint at 16 hours of free time. The vertical distance between the feasible frontier and the biological survival constraint is greatest when Angela works for 11 hours, 13 hours of free time. If Bruno commands Angela to work for 11 hours, she will produce 10 bushels and needs 4 to survive. Bruno will get to keep 6 bushels for himself, the distance AB. If Bruno makes Angela work more than 11 hours, the amount he can take falls as working hours increase. The allocation that maximizes his economic rent is B, where the slope of the biological constraint, MRS, equals the slope of the feasible frontier, MRT, where MRS equals MRT. Voluntary exchange, bargaining, new institutions. Bruno owns the land and Angela owns her labor, no longer a slave. They must now engage in voluntary exchange. Bruno can make an offer that Angela can refuse. Bargaining will determine the allocation. How parties divide up the joint surplus, mutual gains, depends on 1. Each party's reservation option. Point Z. The allocation in which Angela does not work and gets only survival rations from the government is called her reservation option, a person's next best alternative among all options in a particular transaction. Bruno's reservation option is 0. If he cannot agree to an exchange and Angela does not work, he gets nothing. 2. The relative bargaining power between the parties. The curve showing all of the allocations that are just as highly valued by Angela as the reservation option is called her reservation indifference curve, lies above the biological survival constraint. All of the allocations that have the same value for her as the reservation option. Below or to the left of the curve, she is worse off than in her reservation option. Above and to the right, she is better off. The economically feasible set shows all possible allocations that benefit both parties. Coercion versus bargaining. Under coercion, the allocation chosen is where the slope of the biological constraint equals the slope of the feasible frontier. Under coercion, Bruno forced Angela to work 11 hours. The MRT at 11 hours on the feasible frontier is equal to the MRS on Angela's biological survival constraint. Without coercion, joint surplus is maximized where the slope of the reservation indifference curve equals that of the feasible frontier. When Bruno cannot force Angela to work, he should offer a contract in which Angela pays him 4.5 bushels to rent the land. She works for 8 hours where the MRT is equal to the MRS on her reservation indifference curve. If Angela works more or less than 8 hours, the joint surplus is less than 4.5 bushels. Although Bruno cannot coerce Angela, he can get the whole surplus. Since Angela is on her reservation indifference curve, only Bruno benefits from this exchange. All of the joint surplus goes to Bruno. His economic rent, equal to land rent she pays him, is the surplus. Angela ends up working the same number of hours in a voluntary exchange setting that she did when she worked for herself. Total surplus is lower when both parties have to agree to the proposal. The peak of the hump is lower when Angela can refuse compared to when Bruno could order her to work. The Pareto efficiency curve. Pareto efficiency means that no Pareto improvement is possible. It is impossible to change the allocation to make one party better off without making the other worse off. MRS equals MRT means that no Pareto improvement can be achieved by changing Angela's hours of work and hence the amount of grain produced. If the MRS and MRT were not equal, it would be possible to make both better off. For example, if MRT is greater than MRS, Angela could transform an hour of her time into more grain than she would need to get the same utility as before, so the extra grain could make both of them better off. But if MRT equals MRS, then any change in the amount of gain produced would only be exactly what is needed to keep Angela's utility the same as before, given the change in her hours. Pareto efficiency curve, the set of all Pareto efficient allocations, also called the contract curve, joins together all points in the feasible set where MRS equals MRT. The joint surplus is the same, but the distribution of the surplus differs at each point on the curve. As an independent farmer, Angela chose point C, where MRT equals MRS. She consumed 9 bushels of grain. 4.5 bushels would have been enough to put her on her reservation indifference curve at D, but she obtained the whole surplus CD, an additional 4.5 bushels. When Bruno owned the land and made a take-it-or-leave-it offer, she chose a contract in which the land rent was CD, 4.5 bushels. Angela accepted and worked 8 hours. The allocation was at D, and once again MRT equals MRS. The surplus was still CD, but Bruno got it all. Remember that Angela's MRS doesn't change as she consumes more grain. At any point along the line CD, such as G, there is an indifference curve with the same slope, so MRS equals MRT at all of these points. Point G is a hypothetical allocation at which MRS equals MRT. Angela works for 8 hours and 9 bushels of grain are produced. Bruno gets grain CG and Angela gets all the rest. Allocation G is Pareto efficient. All the points making up the line between C and D are Pareto efficient allocations at which MRS equals MRT. The surplus of 4.5 bushels CD is shared between Angela and Bruno. Pareto-efficient bargaining. The allocation chosen will be on the Pareto efficiency curve, line CD. At C, Angela gets all the surplus. At D, Bruno gets all the surplus. In any other point on the curve, Angela and Bruno split the surplus and each receive a rent. Institutions and policies. Legislation. Institutions and policies affect the size of the surplus and its distribution. If Angela and her fellow farm workers lobby for a new law that limits working time to 4 hours a day while requiring that total pay is at least 4.5 bushels, they threaten not to work at all unless the law is passed. Figure shows the effect of an increase in Angela's bargaining power through legislation. The new allocation must give both parties at least as much as their new reservation option. The surplus to be divided between Angela and Bruno is maximized where MRT equals MRS at 8 hours of work. But Angela prefers point F implemented by the legislation because it gives her the same amount of grain but more free time than D. Compared to F, she would prefer any allocation on the Pareto efficiency curve between C and G. At allocation H, Bruno gets the same amount of grain, CH equals EF. Angela is better off than she was at F. She works longer hours but has more than enough grain to compensate her for the loss of free time. F is not Pareto efficient because MRT greater than MRS. If they move to a point on the Pareto efficiency curve between G and H, Angela and Bruno can both be better off. Figure shows the fundamental determinants of economic outcomes. Angela the farmer, lessons learned. Technology and biology determine which allocations are technically feasible. Institutions and policies help determine which allocations are economically feasible, Pareto improving. Points lying in the lens-shaped area between the feasible frontier and the reservation indifference curve. The allocation chosen depends on parties' preferences, what they want, and their bargaining power, their ability to get it. Institutions and inequality. Measuring inequality. Lorentz curve, a useful tool for representing and comparing distributions of income or wealth and showing the extent of inequality. Individuals are arranged in ascending order by how much of this quantity they have, and the cumulative share of the total is then plotted against the cumulative share of the population. For complete equality of income, for example, it would be a straight line with a slope of 1. The extent to which the curve falls below this perfect equality line is a measure of inequality. Invented in 1905 by Max Lorenz (1876 to 1959), an American economist, while he was still a student, it indicates how much disparity there is in income or any other measure across the population. Gini coefficient, measure of inequality, approximated as the deviation of the Lorenz curve from the perfect equality line, ranges from 0, perfect equality, to 1, maximum inequality, given by the area A divided by the area A plus B. The graph shows if there were 100 people in a country composed of 90 farmers who owned no land and 10 landowners who owned all the land. If we plotted the distribution of income in this country using the Lorenz curve, we would find 90 farmers' share of land would be 0, so Lorenz curve coincides with the horizontal axis. Then the share of land goes from 0 to 100 as we look at the share of the land owned by the 10 landowners. The Lorenz curve goes from a point on the horizontal axis to 100 on the vertical axis as the share of the 10 wealthiest landowners is included. If we divide area A, area between Lorenz curve and the line of perfect equality, by the area A plus B, it gives us the Gini coefficient equal to 0.9. Example: pirate ships and the British Navy. Piracy was surprisingly fair and democratic. Unlike in the British Navy, pirates on the Rover distributed their spoils relatively equally between crew members. The Lorenz curve for the pirate ship is closest to the line of perfect equality. Addressing inequality. Redistributive government policies, income tax and transfers can result in a more equal distribution of disposable income. Differences in inequality in disposable income across countries depends on the effectiveness of these policies. The Lorenz curve for market income indicates that the poorest 10% of the population, 10 on the horizontal axis, receive only 0.1% of total income, 0.1 on the vertical axis, and the lower earning half of the population has less than 20% of income. The Gini coefficient is the ratio of area A between the market income curve and the perfect equality line to area A plus B below the perfect equality line, which is 0.47. The amount of inequality in disposable income is much smaller than the inequality in market income. Redistributive policies have a bigger effect towards the bottom of the distribution. The poorest 10% have 4% of total disposable income. Summary 1. Two criteria used to evaluate outcomes. Objective: Pareto efficiency. Subjective: fairness, substantive and procedural justice. 2. Allocations depend on preferences and power/institutions. Institutions can determine reservation options and bargaining power. The Gini coefficient measures the inequality of allocations. Public policies can make allocations more efficient or fairer.